I will now demonstrate the use of the malloc function. This is malloc.c. Let's have a look at what it's trying to do here. First of all, we're going to read in some numbers. We're going to be in a loop here, and we're going to ask the user for 3 different numbers. How many? Well, we're going to ask for 3 numbers in this particular case, and then we're simply going to print those numbers out again. Where are we going to store those numbers? There's going to be 3 numbers, and each one of them is going to be stored. They're all going to be stored in one area of memory, and that memory we're going to ask for from the operating system via the use of malloc. Now, because we're going to use malloc, we need to include stdlib.h, which is short for standard library, or standard C library, which provides prototypes of malloc and free and a whole bunch of other standard C library functions. So, let's begin. This is the pointer. The pointer is called integers. We're going to use that pointer to point to the area of memory that the operating system gives us. And we're going to treat that area of memory, whatever area we get back, we're going to treat it as if it were a collection of integers. Thus, I've got an int here. That's why it's a pointer to an int, because we're going to treat that memory as if it were some integers. How many integers? Well, we've already said that we need 3. And how big is an integer? Well, on this system, an integer is 4 bytes. On your system, it will probably be 4, although it could possibly be 2. I'll assume it's 4, so that gives us a total size of 12 bytes. So we're going to need 12 bytes from the operating system as a malloc. So let's do that. Actually, before I do, this is where we're going to do it. This is where we're actually going to set the integers pointer to point to something. And then here we're going to reference each of the 3 numbers. We're going to read them in, and here we're going to print them out. So we've got 3 bits that have to be filled in order for this program to work. Let's see what the first one of those is. It's going to be a malloc. Malloc of what? Well, we could say simply a malloc of 12 bytes. That will do it for us. But I don't like that very much. 12 is a bit of a magic number. If you took this system and compiled it now on, say, a DOS system where integers are only 2 bytes in size, then that would give you, well, it would give you 6 integers, not 3 integers. So I'd rather do it like this. I'd say the required number of integers times the size of an integer. That is more portable. I like that a lot better. No magic numbers. Now, remember I said that you must test to see whether the value that you got back is null. You must. Well, you don't have to, but I really strongly recommend it. And then you might then say, well, if that is null, then we've got a serious problem because we're out of memory or something's wrong. So we can say malloc failed. And what do we do then? Well, we've really got to crash out of the entire program. We've got to just stop execution right at this particular point. I'll use a function called exit to do that. You don't know what exit is yet, you haven't seen it. It is another function from the standard C library, and there's actually a module on the exit function in a later chapter. So I'll talk to you about it then. But you can pretty much guess that it's going to simply exit the program at this particular point. Good. That's the easy bit done. Now, here's the tricky part. What do I put here? Well, I'll show you what I put here and then I'll explain it. Integers, square brackets, I. That makes it look like integers is an array. But integers is not an array. Integers is simply a pointer, a reference to a memory address. And if you recall from the last module, I told you that pointers and arrays are almost interchangeable. The significant difference between pointers and arrays is that arrays already have a whole chunk of memory allocated to them, stack memory, whereas pointers don't. You've either got to take a pointer and set it to an area of memory that already exists, or you've got to allocate some memory using malloc from the heap. Once you've allocated that memory, you can treat integers and arrays as exactly the same, except of course for that proviso about the size of operator. Don't confuse them in that sense. Don't use size of with a pointer and expect it to get the size of the entire memory block. Integers and arrays are virtually interchangeable. it allows this kind of construct. This might look awfully confusing to you, but think about it like this. What if integers just happen to be an array? What if I had an array called integers? How big would it be? Well, if it was 3 elements, how many bytes would it take up? Well, it would be 3 lots of 4 bytes, so it would be 12 bytes. If we had an array called integers, it would be 12 bytes long. And now we have a bit of heap memory, which is 12 bytes long. I'm asserting, and the compiler will back me up on this, that you can treat them as exactly the same thing. This will actually compile with no errors. That might be surprising to you at the moment, but when I explain in a later chapter the similarity between pointers and integers, then I think you'll fully understand. Anyway, I'm going to take that and copy that and paste that. Copy that and paste that here. And let's try and compile and run that. I know that you're probably not expecting this to compile because of this very strange bit of code here, but I promise you that it will. Let's prove that. No errors. That's quite significant. The fact that we got no errors means the compiler did not have a problem with that bit of code. Well, let's see if it actually worked. That will be the proof of the pudding. Please enter number 1. We'll call that 23, 45, 56. And it is working. Okay, that's great. I know that's quite a complex bit of code. In other words, you won't have seen pointers being used as arrays before, so I encourage you to actually pull up this file, malloc.c, out of the chapter 15 folder, and really have a bit of a play with it. See if you can compile it yourself, test it, make sure it works, and then make sure that you understand it in your head. And I promise, go into that in a later chapter, the similarity between pointers and arrays. Anyway, let's move on now and look at the flip side of malloc, and that is free.